Okay, so before we learn further about the application of derivative, first we have to know about the use of the derivative itself in our life. First, in economical subject, derivatives are used to determine the marginal cost and the revenue cost of any products. And then in my major, mechanical engineering, it is used to determine and calculate statics, dynamics, mechanics of solids, fluid mechanics, gravitation, thermodynamics, and kinetic theory of gases, heat flow and transfer, simple harmonic motion, oscillation and waves, micro electromechanical system, control theory, whirling of shafts, Laplace's equation, vibrating membranes and mechanical vibration, two-dimensional heat flow, and two-dimensional wave equation.
Application of derivative. Basic form of derivative function is f prime x. We always use this form of this function of derivative. So this video will explain the basic theorem of using derivatives in daily problems, or we can say how engineers use derivatives. So first is either the function increasing or decreasing. So first we have to determine if the function is naturally increasing or decreasing. By looking at the graph, we know that this function is naturally increasing because the value of fx is increasing too. And this is how the decreasing graphic looks like, because the value of fx is decreasing too. Second is how to find the maximum or minimum value in derivatives, using derivatives. Basically, for a function, if we have to find the maximum value, we can use derivatives. So this is the graphs, and this is the maximum value. And this is when the graph reaching the minimum value.
The example one of the application of derivatives. About the example of application of derivative. So the example question is the production cost function is 8x squared minus 120x, and the item price is 1 over 3 x squared minus 10x plus 200. And the profit formula is all item times cost and minus production cost. So how much item that sold, we put it x, and then times the item price 1 over 3 x squared minus 10x plus 200, and then minus the production cost function 8x squared minus 120x. So we put the x inside this function, and then we get 3x minus 10x squared plus 200x minus 8x squared minus 120x, and we get 1 over 3x minus 18x squared plus 220x. So after we get this function, we need to derivative this function. So the derivative equals 0. So So we get x squared minus 36x plus 320 and equals 0. So open this up. So x minus 16, x minus 20 equals 0. So the first function x equals 16 or x equals 20. So the item that have to be solved is 16 or 20, and that's it.
Now I'm gonna tell you the second problem of derivative.
Now we're gonna find the solution of the difficult problem. This is a water pipe made from metal plate that had 30 centimeters width, with folding the width to the same three pieces, 10 centimeters, 10 centimeters, and 10 centimeters. If theta represents the angle of the wall of the water pipe to the bottom of the water pipe, this is the theta. So the water volume can contain if theta. To get maximum water volume, trapezium surface equals to 0. Okay, this is A and this is the B. A is equal to B, and then 10 times sinus x. The T is the height, is 10 times cos x. Okay, now this is the surface trapezium formula. Okay, 1.5 and P is this, is 10 centimeters. Okay, 10 plus, and then this Q, A plus B plus 10 times T. So half 10 plus 10 sinus x plus 10 sinus x plus 10 and times by 10 cosinus x, and then 1.5 10 plus 20 sinus x plus 10 and times 10 cos x, 1.5 20 sinus x plus 20 times 10 cos x, and then the half is by this, so this becomes 10 and this becomes 10. 10 sinus x plus 10 times 10 cosinus x. Okay. So this is 100 sinus x cos x plus 100 cos x. So this is divided by 2. 50 times 2 sinus x cos x plus 100 cos x. So 50 sinus 2x plus 100 cos x. This is the formula of the trapezium surface. Now the trapezium surface get the maximum water volume if equals to 0. Now this is 50 sinus 2x plus 100 cosinus x equals to 0. So get a derivative. 100 cos 2x minus 100 sinus x equals to 0. 100 1 minus 2 sinus square x minus 100 sinus x equals to 0, and then you times this. 100 minus 200 sinus squared x minus 100 sinus x equals to 0. Minus 200 sinus squared x minus 100 sinus x minus 100 equals to 0. So the equation is minus 2 sinus squared x minus sinus x plus 1 0. This dibagi sama 100 and then times by minus 1, so 2 sinus squared x plus sinus x minus 1. So the result is 2 sinus x minus 1 sinus x plus 1 equals to 0. So the sinus x can be 1 and 1.5, or sinus x becomes 1. No, we get these two solution, but because the x is 30, so the angle of theta is 90 minus 30, so 60 degrees. The sinus 60 degrees is 1.5.